Welcome back to the channel, everyone. So today we are going to look at a regular polygon, happens to be a decagon. And then you can see it's been inscribed inside a circle, and we're just gonna try to find different angles within this polygon. Okay. All right, so decagon, right? Well, what does that mean? The deca has to do with how many sides it has. And I wanna say 10, but let's just count it, right? 1, 2, 3, 4. Let me just number it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So there's 10 sides to this polygon. Regular means that all the sides are the same length. Okay. All right. So let's try to find some angle measures. And one thing you'll notice is that they've kind of already started to divide the polygon into right triangles. So we have the right triangle PLK and PLJ. Okay. All right. Well, what if we just keep dividing the entire decagon into these right triangles? How many would we have? Okay, so we already have 2. So this would be 3, 4, 5, 6, 7, 8, 9, 10. So going halfway around, we have 10 right triangles. So we're going to get 10 more for a total of 20. 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so we have here 20 right triangles that compose or make up this entire polygon. Well, and remember, this polygon is inscribed inside of a circle. If we think about the entire, central angle or degrees of a circle, right, it's 360. Right? So if we take the 360 degrees, right, full rotation of a circle, divided by how many right triangles we have, right, divided by 20, right, that should give us the angle, right, the central angle of each of these little triangles. Okay. So 360 divided by 20 is 18 degrees. Okay. All right, so I'll zoom in here real close and we'll mark that angle there as 18 degrees. We can mark this angle here as well, 18 degrees. And we can actually mark every one of those angles. I'm not going to do it because it's really, really small. I would have to write really, really small. Okay. So let's start measuring some angles. KPJ, right? So K to P to J, okay? So that would be, the angle they're talking about is this wider angle here, right? The sum of those two angles, right? 18 and 18, that'd be 36 degrees. All right, how about the measure of angle LPK, right? So LPK, it represents the angle of just one of those triangles, right? So that 18 degrees. And then the third question is to find the measure of angle LJP. Okay. So LJP, let's use another color, is that angle right there. So let's just focus on that triangle, right? I'll draw it here best as I can. Okay, so this is P, the center of the circle. That's J, and that's L, right? Notice that we have a right angle here, which means that we're going to have a right angle on the opposite side. And we know that this is 18 degrees. All right, so what is angle LJP? Right? This angle right there, let's call it X. Well, something we learned way back at the beginning of the year is that the sum of the interior angles of any triangle is 180, right? So I can say X plus 90 plus 18 has to sum to 180, right? Those two angles there will be 108, so X plus 108 equals 180, sorry. And then if we subtract 108 from both sides, we should get a remainder of 72 degrees. So that's our third and final answer there. Right, just use the triangle sum theorem. All right, so in future videos, you're going to see a common theme, which is to take these regular polygons and to divide them into similar right triangles. So thank you for watching, and I will see you in the next video coming up shortly.